Hi,
Um,
Steve. Nice to see you again. How you doing?
Hi, yeah, I'm back. Yeah, good to see you also. Yeah. Actually, I just now sort of finished watching your video on the music of life.
Uh-huh.
I was completely blown away. That is just so awesome. All the way down to the DNA and resonating back and forth. That's just absolutely awesome.
Well, I
I
knew you would like that. That's why I came to visit you.
Yeah. Well, I'd had thoughts like that myself about because when you look at a DNA strand, physically it's like a slinky. It's kind of stiff but kind of wobbly, and then there are the zones in between where what gets snipped off and muted so it can resonate by itself, and then it talks to other. That is just, I think you're really onto something there with a level of detail and specificity that I've never seen before. So congratulations on those thoughts. Hope they push you along.
Thank you so much, Steve.
A
That's
big
really
thing.
great to have that feedback. I really appreciate it. There's still lots of gaps, but I feel like the enough of the whole is there to know that the gaps can be filled rather than.
Yeah, and you got some great little pointers of evidence here and there of what was those I forget what you call them, the genes that go along the body. And
Uh-huh.
I always wondered about that too. Why is it that those genes have a mapping similar to the body? And
Yeah, the Hox genes,
obviously
yeah.
there must be like a resonance wave that travels down the body in synchrony with the resonance wave going down those genes, and they map with each other. And that's an answer to an otherwise very perplexing phenomenon.
Yeah, when you take it as a toolbox of protein building blocks, that doesn't make sense. But when you think of it as a dynamical system that unfolds in a particular
Right.
temporal window, it does.
It's a whole different paradigm. It's like you nailed the last nail in the coffin of the old-fashioned. I believed all that stuff. The
Job
protein,
done. Job done.
the
Thank
DNA
you.
making the proteins, and the proteins making the cell. It makes sense, and it's true at one level. But there's a big missing piece there that you've really unveiled.
Cool. Hi, Adam. Hi, Lars.
Hey,
Nice to
Richard.
see you
Nice to see you,
guys.
Richard. Very
Yeah,
excited to
Great
hear
to
you
see
today.
you.
yeah.
Looking
You
forward to it.
guys, Adam and Lars, if you guys could introduce yourselves, and also Mary and Stephen, because in this forum we haven't heard from you guys yet, and
For
actually we
sure.
haven't heard from Richard yet either. So,
Happy to start. I'm Adam Goldstein. I'm in Berkeley, California, formerly a student of Michael Levin and then of Dennis Noble at Oxford. These days, I work on research in AI alignment, trying to draw inspiration from biological alignment, symbiotic organisms, and cellular communication.
awesome, Lars.
Nice. I'm Lars. My research background is in the applying the free energy principle and active inference to meditation research. So I'm looking at questions around sort of metacognition, self-awareness, and trying to formalize meditation practice in the language of statistical physics. And then that's what brought me into contact with Adam, actually, and kind of bringing these into the world of AI as a way of kind of bringing so these principles of compassion and self-awareness and no self into hopefully some future AI architectures.
Awesome, Mary. Do you want to introduce yourself?
Hi, everyone. Um, I have no idea how to introduce myself in this context. I was trained a very long time ago in between stints being trained in the arts as a molecular biologist, and did a brief stint of research. I didn't even publish. It was a short period of time where I was looking at the structure of microtubules, and I was very interested in ideas that were introduced by Albrecht Buehler in the physiology course at Woods Hole about the intelligence in the cytoplasm. And I've kept up in that realm ever since because it's interesting to me. But I've since gone on to really develop my intuitive, creative side, and I have a practice that I can only describe as shamanic, um, as well as being involved with, um, let's just say, a change in consciousness in some global and local level activist work. But it all has to do with what I would call an emergent conversation around these ideas of agency and panpsychism and pansentience, and let's proceed.
Awesome. Stephen?
Yeah, my turn. I started in doing neural network theory and computational processes in vision. So I did a lot of image processing and trying to recognize what was going on. And I stumbled on the harmonic resonance as an explanation to address the combinatorial explosion in the number of feature detector cells and so forth that you would need. And then I also went on a deep psychonautical journey, taking all kinds of hallucinogens. And I kept seeing patterns, symmetrical, periodic, radiation, everything, all different kinds of patterns. And I realized that the way the brain does it is with waves and resonance. So that's been my focus all along. And when it gets down to all the way down to the bottom of the question of consciousness, where does it originate? And I think we are stuck with a paradox that either consciousness is like a spiritual, non-physical, something that supervenes on top of, whatever undetectable, unverifiable scientific means, or consciousness is physical matter. And it comes down to the basic idea that if you believe that the brain is a physical mechanism, and if you believe, not everyone does, that consciousness is a function of the brain, that already conclusively says that a physical process taking place in a physical mechanism can, under certain circumstances, be conscious. So it connects all the way down to the bottom, and even an atom is conscious. It's a wave, it's a resonance, it's a standing wave. So it's got its own consciousness of itself.
Yeah, or physical matter and consciousness aren't different things.
Right. It's the only true monism. They're all the same thing. Yeah, exactly.
Yeah. Oh, Bill Miller's just joined us.
Howdy, thank you for hosting this.
Yeah, absolutely. Yeah. So, well, you guys all know me. I'm Charlie Munford. I'm the founder of Talking Octopus. Talking Octopus, an organization that's trying to build a physical model of agential biology. And we've been having these conversations because I think we're all united by this intuition that all cells are conscious, all cells have their own agency, and that there's some physical mechanism underpinning that. And so our reading has sort of ranged a little bit, different topics. Last time we met, which was 3 weeks ago or so, we tried to deal a little bit with some of the implications of cell-based consciousness theory, which Dr. Miller and Franciszek Belushka and several others have invented. And before that, we dealt with Johann Jaeger's theory of agency, which Lars, you may be interested in, and you may already know about his paper, but a lot of us had sort of different intuitions from that paper, but it definitely connects to inactivism and that sort of predictive processing model of cognition. And so this time, we're here to discuss Richard's theory, which is, I think, the most exciting thing out there. It's a really deep idea. and it has lots of ins and outs. And Stephen Lehar and I have been meeting regularly to talk about some of the implications and try and devise, actual analog experiments or digital replicas of analog experiments that we could propose to sort of take the inquiry a little bit further. But yeah, I wanted to maybe start by just asking Richard if he felt like the Philip Ball video framed his question, or if it missed his question, or how did you like that introduction?
Yeah, so I mean, as an overview of all the reasons why the conventional model doesn't hold up, that's a good intro. So the step that I want to go next is, but if the conventional model doesn't hold up, then natural selection doesn't hold up. So what explains the adaptive organization of living things if natural selection doesn't hold up? So yeah, I think that is a good way to enter into the, because you say, what do you work on? Well, I'm working on a new theory of evolution, and the knee-jerk reaction is we've already got a theory of evolution that does everything we need. And it's like, so you need people to be talking about how full of shit that is in order to be able to begin the conversation about what could provide a better explanation for the adaptive organization of living things.
I was thinking of it this way. I mean, this is a sort of simplistic way, but sometimes it's nice to just be as simple as possible. Because I was thinking, okay, natural selection is a historical theory, right? It's not a physical theory. And so let's suppose we just had a historical theory of lava, and we just said, oh, well, lava is the thing that gets here onto the surface by being smushed out of the inside of the earth. Why is it hot? Well, it's hot because it's hot down in the inside of the earth. But if you have a physical theory of lava, then you know how to make lava. And you can melt rocks and make them into lava because that's what lava is. And so that's kind of how I think of the difference between harmonic resonance or whatever the mechanism is that we haven't quite discovered. That's
but the believers think that the algorithm of natural selection is a physical mechanism of how you create that stuff, but they're just believe that by faith.
Right, but I mean, the simple way to disprove that is you just ask the question, okay, so you're a lineage of cells that's in a multicellular organism, and you're dividing from the initial zygote. So how do you make your decision about what to divide into? Like you don't receive any signal from natural selection. Like you've got the same signal that your next door cell has, right? So at the boundary between every tissue, the cells are making opposite decisions about which tissue to become. Well, they've all got the same inheritance, and there's absolutely no signal from natural selection that's different between the one cell and the next door cell. So,
yeah.
That's
I saw you raised that question in the previous recording, which was great. Yeah, I take your point there. Yeah.
Well, I learned it from you in a way. I mean, I heard you ask that question, and that alerted me to its significance.
Charlie?
Yes, sir.
I want to start off by saying to Richard, I remember meeting you at the cognitive neuroscience meeting. We
talked about the animals, didn't we?
Yeah, it was terrific, and your presentation there was terrific, really excellent. I found it fascinating. I think the material you sent is great. And I think you started off by saying the single most pertinent question in all of biology right now: natural selection doesn't hold up. So there is an answer to that. It isn't an answer that everybody likes, but my colleagues and I, that's Frantisek, Balushka, and Arthur Reber, and Predrag Slavicevic, I always have to struggle with that one. We published a paper in Progress, and it is natural selection is cognitive selection. And it's the simplest of approaches. We don't claim to understand how cognition began. How did cellular competence begin? We don't know. However, we can state, and there is actual proof through stromatolites, that competence began in the way we identify the first living cells. So the origin of life equals the origin of cognitive competence on this planet, embodied in the cellular form. That's the evidence we have. What do we make of it? And the answer is, once you start with cognitive competence, then all of selection is cognitive selection. And natural selection can now be understood in its proper role as a post facto filter of precedent variations, which are stimulated through cognitive variation. I think your work elegantly offers some of the essential background that's necessary to understand that where the cognitive competence is coming from. Where does it enact? And it enacts through harmonics and other things that we're learning how to explore. It's beyond thermodynamic flows. And I think your work is illuminating in that regard.
Cool. Thanks so much, Bill. Yeah, I enjoyed that meeting that we had back in UCLA. I think that's right. So we're very much on the same wavelength there. I'm viewing biological evolution, by which I do not mean evolution by natural selection. Biological evolution, construed more broadly, is a fundamentally cognitive process. That makes sense to me. And yeah, I want to understand how cognitive processes can arise de novo and how cognitive processes can get smarter over time, so that we have a mechanism for how that works. And the resistance will be, of course, that if you don't have a mechanism for where the cognition comes from, then any evidence that you have that there is cognition will simply be dismissed and ignored, right? Because it can't be. How do you know it can't be? Because evolution by natural selection is the only mechanism that can produce adaptive organization, and it's not that. So whatever you're selling us must be wrong, right? I imagine you've met plenty of resistance of that form, right?
Well, certainly you can't argue with what people want to believe, but people seem to forget that the neo-Darwinian edifice rests on things that are simply not understood at all. No one understands how competent replication occurs. No one understands how nearly flawless replication began. And everybody's completely comfortable with assuming that as a baseline. I'm just suggesting a different baseline. And if you do that, then you have a natural learning system. You have evolution based on continuous cellular problem solving. And the virome becomes a partner rather than pure competitor. And it's a useful alternative narrative. And its weakness is absolutely, just as you say, I have no idea how cognition began. But it hasn't stopped the neo-Darwinists from being triumphant.
Yeah.
I have a
Wayne's got his hand. Wayne's got his hand raised, and Stephen, you're next.
okay.
Oh, Wayne,
I can't hear you.
You're on mute, Wayne. You're muted. Oh, you're still muted.
Okay, can you hear me now?
There
Yes.
you are. Yes.
Very good, very good. Sorry about that. Yeah, so only place I kind of want to push back a little bit. So when we get to, the extended evolutionary synthesis, a lot of those processes would be cognitive in nature, in one way or another. Niche construction and, the developmental niche construction, et cetera. But then you have another kind of process that Terry Deacon talks about, which is redundancy and relaxation of selection. I'm not sure if folks are familiar with that idea. Some good examples are gene duplication events. Where you and other examples are dietary changes, where you have primates. They develop, they start eating fruit. The genes which encode for the final process in creating vitamin C are relaxed under selection. They begin to deteriorate, and the mutations that have been selected for actually tend to support color vision, which helps in finding fruits that are ripe and ready to eat. There's, of course, a semiotic interaction with the plant. doing the, the color on the fruit so that the organisms eat it at the right time. So all I'm saying is that it's clear that evolution by natural selection and evolution by this Baldwin effect or whatever, are going on. They're just not the whole story, right?
Yeah, and so they connect up this way for me.
Okay.
That I think of the genetic evolution as the long-term memory that stores the solutions that have already been found by the learning process, by the cognitive process.
Very good.
And the Baldwin effect can do that. And if you have a Baldwin effect guiding the natural selection, variation and natural selection process, then you still have a natural selection process. And if that's what you want to see, that's what you'll see. But why the selective field had the structure that it did and that led you towards a particular adaptive solution is not explained by the variation and selection. It's explained by the fact that you already had a solution that was applying those selective pressures onto the genetic variation.
Okay, I mean,
but those two things together still don't explain. But how did you have a solution in the first place? How did you learn the cognitive? Where did the cognition come from? How did you learn a solution so that it could then guide the evolutionary process?
Fair enough. Yeah, I mean, I look at variation and selection as it's generally pictured as sort of something that's abstracted from something that's much bigger. So we have this enormous evolutionary process, and we take a piece out of it, and we can actually work within the lab, and we can use it in various ways, and it explains certain things, especially if you look for the right things. But there's a lot more going on there. I mean, that's good. That's kind of the way I see it.
Cool, Steve.
Yeah, I was a little unclear on what you mean by cognitive. I understand there's that learning involved. And, in both computer science and in psychology, we have the distinction between sensory experience, the raw colors that you see, and the cognitive, which is an abstraction, a reduction into abstracted terms of what we think we're seeing. But I think, as I understand your way of thinking, it's not just at what I would think the cognitive level, but the cognitive level is totally coupled with all levels below and above. And therefore, when you have a cognitive thought like, I think there should be a triangle, and you have a sensory experience, there it is, I see the triangle, that it's the cognitive, it's not really the cognitive, it's the whole stack.
So, so for me, I'm using cognitive in a very relatively uncontroversial algorithmic sense of a capacity for memory, a capacity for learning, and a capacity for adaptive behavior and problem solving. And things like whether you have a subjective experience of it, or whether there's any affect or valence to what you're doing, or whether you have a conscious experience of it, are topics that I'm interested in, but I don't know how to access yet. I don't know how to tread in those domains yet. So by cognitive, I'm using it just to say, I want to be able to do the kind of computational problem solving that we're used to doing with an artificial neural network. Whether the artificial neural network has a subjective experience of what it's doing like a real neural network does, and why it does, or whether it doesn't and why it doesn't, I don't know. But if we could get physical stuff to do that kind of algorithmic computational stuff, that would do a lot of work, and it would do more work than natural selection does. And it's at least taking us in steps which are in a useful direction for those other questions too.
So when, for example, an electron joins an atom and becomes one of the electrons in that cell, it sort of elbows and muscles its way between the other electrons that are already there, and it comes up with a solution which is a nice symmetrical pattern, and
and all the other electrons breathe a little sigh of relief. Yeah.
But is that cognition? Because it doesn't have the memory aspect to it, but it seems to me it has the intelligent aspect to it, even at the lowest level of matter, is that there's somewhat, using your term, I'd say there's a cognition going on, how these electrons resolve their pattern in space.
Yeah. So to the difference, I mean, not all physics is cognition, right? There has to be something special about it. Otherwise, we're just saying, you know, anything doing anything is cognition. But on the other hand, the difference between a physical system which is cognitive and physical system which isn't, A, it's a matter of degree, and B, it's a matter of scale, and C, it's a matter of perspective and frame of reference as well, right? So when you take a particular projection or frame of reference on a physical system, which pretends that you can't see some of the detail that is behind it, right? So you're just looking at a surface and you're not looking at all of the hidden variables. That can behave in a cognitive way to the extent that it has an appropriate inductive bias that does mirroring across that boundary, if you choose to look at it that way. But if you choose to look behind and look at all of the gubbins that's inside, well, then you won't see it as an agent. You won't see it as something cognitive. You'll just see it as, oh, that's just things pulling and pushing. I don't see any, I'm just seeing physics there. So I think that there's, you know, I don't want to have like, I want the meaning of the word cognition to mean something and not just mean anything that any physics does is cognition.
Yeah,
on
well,
the other
that's
hand, I am open to the idea that cognition goes all the way down, right? So that
yeah, but it might be appropriate to rename it because cognition already has its meaning. I think it does go all the way down, and that even a rock has consciousness of its own structure. If you don't believe it, try chipping off a corner. It resists really hard. If it sits in the sun, its sunny side expands and warms up, and all of the little atoms bounce around in it. In my view, it has consciousness, and it has cognition in the sense that if it's in the noonday sun, it gets warm on that side. That's the kind of cognition, you know. Maybe the word cognition is not quite right, because I actually do believe that every physical process is itself like, you know, physics and experience are one and the same. They're not two different things. Dualism, get rid of it all the way down to the very bottom and endow the simple atom with a certain basic cognitive consciousness, you know, whether you want to use that word or not. But it is, in my view, the argument is it goes all the way down to the bottom. And I think you kind of agree with that.
Yeah, I kind of do, but I want to make sure that we don't lose the meaning of the term altogether when we do that.
Charlie, we're
Adam
talking about cognition. I'm sorry to jump in, and I know people have their hands up, but we're talking about cognition. And I think there is one useful thing I can offer. There is a formal definition of cellular cognition, basal cognition, which I defined in 2016. And it's the same definition that Mike Levin works with and Pam Lyon. It's in the paper that I wrote. I'll read it. It sounds awfully formal, but it makes an important point. Basal cognition is the suite of self-referential cellular competencies possessed by all cells that permit the measured assessment of ambiguous information and its further communication and deployment to enable individual and collective problem solving. So what is cognition? Cognition is the capacity to problem solve. And where that begins, we can debate. Richard is doing fantastic work trying to solve the greatest mystery that's left in biology, from my perspective. Why are we cognitive agents? Where do we get our cognitive agency? And I think his work is terrific. But let's not forget, cognition is a verb. It's not really a noun. It's an active process of problem solving and learning. And we can either start with that at the basal level of the living form or not. And we can debate all we want about how it came to be, and I think we should. I think that's something that we must understand eventually. But we can build a very powerful system that improves our ability in bioengineering and lots of other things by understanding that each of our cells as individual nodal agents are individually intelligent problem solving. And we can work with that creativity to enhance our lives. So we have a very big difference between neo-Darwinism and cognition-based biology and evolution.
Let's hear Adam.
Sure. Yeah, I just thought I'd throw out a thought experiment that I've been giving some thought to recently to try to tease out this question of, physical selection and algorithms and how they might interplay. There's a story that we have about cancer cells that the reason that they spread, that they proliferate, is because it's somehow advantageous to the cells from a reproductive, and selection standpoint. That the cancer cells are somehow more fit, at least in the short term, obviously not long term, and that gives rise to this proliferation of cells. That's a traditional explanation, but it isn't the only explanation you could have for why cancer cells proliferate. Another possibility is that individual cancer cells are actually less likely to survive and divide by virtue of that phenotype, but they make up for it by being really good at persuading their neighbors to become cancerous. And by the way, I'm not saying that that's correct. Maybe it is, maybe it isn't, but just that both of those would be consistent explanations for the observation. You see a bunch of cancer cells, you ignoring how, if you, like on day 1, you see 2, on day 10, you see 2,000. One story is that the cells divided, another is that they just persuaded a bunch of other cells to become cancerous. And which it is, or which ratio it is, I think is going to be contingent. It's going to be a function of the specifics of the environment and, the cells and all sorts of other things. And the reason I like this as a thought experiment is because it highlights the risk in adopting the purely traditional approach, which is that, it's all about selection, but also potentially the risk of adopting a pure algorithmic approach. Oh, the algorithms are in the driver's seat. It's cognition that's driving the process. Where I've come out is that it's probably better to think of this as a joint equilibrium or a summation or something like that of both the physical, traditional selection-based things and the algorithmic. And they're both competing and cooperating. The algorithms are both competing and cooperating with the underlying physical agents. And what we see is the emergent integration of the two. So throwing that out in case others find that useful or have contrary ideas.
Mary, did you have a?
Yeah, I hope folks don't mind if I put my questions in the chat so I don't forget them as we go. And so in case anyone wants to look there too. So as I've been delving more and more into this field, I'm seeing a lot of folks who are working with some a prioris about our collective experience, like the linearity of time, that are concerning to me, because when I tune into what's really going on, my questions are much more messy. They're much more like Robert Lanza's questions. And I'm wondering if folks here have read Robert Lanza. He talks a lot about the concern that or the evidence, and the evidence from experiments that we understand and iterations of them and refinements of them, like the double slit, that indicate that consciousness comes first. So if consciousness comes first, then all of this talking about mechanisms and models of mechanisms, the way that we are doing here, is a little bit like the hammer and the nail cliche, or maybe the drunk who is searching for his keys under the streetlight because there's light there, even though his car is down the street. So when I tune in, what I see is that the questions are things like, what happens in the condensate, at the beginning of cell division or replication? And has anyone read May Wan Ho?
Yes.
Okay. So I think I've sent her to a few people because she hints at the electric theory of the universe what happens in the condensate? You know, what's directing that? And is there a consciousness which is maybe an electric, or I hate to invoke the ether, you'll have to forgive me, but another driving agentic quality? I mean, we have to keep coming back to that word, that's organizing the exclusion layers, you know, and directing a current that's shaping what then emerges. And is that even linear? So forgive me for, I see things in terms of really these sort of larger shamanic philosophical questions.
Yeah, I have a lot of sympathy, and the word that comes to mind is joy from thinking about things that's not the way that I said I think about things just a moment ago, right? So I can see the danger of saying, well, I don't really know what consciousness is, but I know what memory, learning, and adaptive behavior is, and I don't need to worry about sentience, and I don't need to worry about value, and I don't need to worry about first-person experience. We'll come to that later. And I can see the danger of taking that attitude. It's a very conventional attitude. And I see the excitement of saying, what if you didn't start there? What if you started on the other side? What if you started with sentience? What if you started with feeling? What if you started with experience and subjectivity? I still don't know what to do about it, but I see the excitement of it, right? I'm attracted to that.
Can I chip in with?
Can I just respond a little bit?
Oh, sure, go ahead.
So, I feel a little bit like we're still digging around in the brain looking for the homunculus.
Yeah.
Right. Right. Yeah, I mean, I actually disagree with the I think I disagree with the definition that there's a commonality between what Dr. Miller and what Richard have been saying in some respect about problem solving. And so like the one aspect of your ideas that I would push back on, Richard, is the concept of optimization or problem solving, because I think our idea of a problem is necessarily linked with this aim of survival and reproduction. And so if we can somehow, if we redefine or rename problem solving as developing an understanding of the world, a subjectivity, then it makes sense, because in order to solve a problem, you have to be aware that it's a problem. And in order for this theory to work, it has to be an awareness that's prior to that awareness being shaped in such a way that it can recognize or incidentally, unintentionally result in a mechanism that survives and reproduces. Because, I mean, you know, as we were just saying, there's no signal from natural selection when this harmonic resonance, or what I call epistolution, is happening. So, you know, it's prior to that, and it's completely divorceable. To me, the goal that I've had for 5 years is to build models that are, because I think it's completely divorceable from evolutionary history. They're physical models that are independent of any evolutionary history, but that are able to learn. And so it's sort of the concept of something that can problem solve. When we say that, I think almost universally everyone misunderstands that as something that can, you know, pursue its own existence as a sort of telos, you know, that can make itself persist in the world. I think that's an incidental side effect of making your own point of view persist in the world, right?
Yeah, I totally agree, Charlie. I totally don't mean to use problem solving in the sense of solving the problem of survival and reproduction, right? That is not. That's a survival and reproduction is part of the attempted explanation for adaptation. It's not what the adaptation is. The adaptation isn't about survival and reproduction. Survival and reproduction is part of the mechanism for supposedly producing adaptation. It's the adaptation that we're interested in, not the survival and reproduction. And I agree with you that problem solving as a phrase or term is problematic. because it suggests that there's a problem out there already. It suggests that you're doing a sort of a fixed optimization process against an objective function of some kind, and all sorts of problems there. For me, I agree with you that knowledge of the environment, knowledge of non-self, is a better thing, a step in the right direction of what is the thing that's increasing when you're doing problem solving rather than survival and reproduction. But that obviously begs the question of, well, how do you know that it's knowledge and not just something inside you that changed? Like, how do you know it's knowledge because it's useful? It's useful for doing what, right? So you have all of it begs a lot of other questions straight away. Right. Mechanistically, I think what I mean by it is finding configurations that resolve many constraints simultaneously, where the constraints are defined by the goals of the parts, and that's a recursive definition that pushes the definition of problem solving at this level down to problem solving at the level below. But I don't think it's a recursion which becomes a useless tautology. I think it's a way of thinking about it that actually makes sense biologically. So you have this sort of scale-free notion of cognition. And of course, I want to connect that to harmony, right? So the songs of life, right. One of the implications of the songs of life and mind idea is what it says about the prime mover, right? What's the prime mover here? Is the prime mover survival? Is the prime mover persistence? Is the prime mover reproduction? What is it? And it says, well, it isn't any of those things. And in fact, if you said, well, is it harmony then? Is it like I'm trying to maximize the amount of harmony? I'm trying to do the best song, is that what I'm trying to maximize? What the hell does that mean, right? And it's like, well, it sort of does mean that. But the thing about maximizing harmony is, as soon as you take a step in the direction of increasing harmony, you change what the right answer to the harmony is, right? As soon as you make a move, you change the space into which you are moving, right? So there is no static objective function because you're in the system, right? And it's in that way it's the idea of imagining that problem solving is a fixed thing out there that you're solving. When you think about it as harmonizing rather than problem solving, then you end up with something like Andrea Hyatt would call waymaking rather than optimization or problem solving. So I agree with you. I can quantify. I find it useful to say problem solving because I can quantify how good a system is at solving a problem, and that helps me say something concrete. But I'm not conceptually attached to it in a deep way.
Right.
Definitely not in a conventional way.
I was really struck by the end of your part of songs, the second part of songs, when I watched it again this morning, because Stephen and I have been working over this problem. So if I understand you correctly, what you're saying is unique about the harmony in living things is that they're sensitive, that the higher scales are sensitive to the lower scales, as well as the lower scales being sensitive to the higher scales. So the way I understand that, and because I've been puzzling over this metaphor of, just a simple resonator like a trumpet, the trumpet has no memory of the notes that you played on it before, except to the extent that it's been beaten up by, by heat. It hasn't changed its point of view based on what songs you played on it, and so I'm trying to figure out what is the physical principle there that allows
but the resonating air does have memory. The resonating air in the trumpet is the time scale that you want to be thinking about.
Okay, but it to me, well, correct me if I'm wrong, but it seems like the trumpet, the lower scales are sensitive to the higher scale, but not the reverse. Like the trumpet doesn't accumulate complexity. The trumpet doesn't respond at a macro scale to the memories it's created at a micro scale. And
I would agree. So I would say that the metal of the trumpet doesn't participate very much in the song, right? The song that is organic, that is alive, is the resonating air. And that, whilst that persists, whilst that rings, whilst that sings, it does hold a memory of the resonances which have come before. So, you know, not, I'm, so this connects with what Steve said about, you know, the rock is a little bit cognitive, right? So that for me, the thing that makes the difference between whether something is cognitive or not is how richly are connected the different levels of organization. So in inanimate objects, the connection between different levels of organization is very weak, so that they don't talk to each other very well, right? And the fact that to the extent that a trumpet has a physical structure that isn't changed by the song that you sang on it, so that next time you play a song on it, it's the same trumpet. To the extent that it's not changed by that, it's not really participating in the song. And it's a vessel for the song, but the organic stuff is going on within that vessel. And you know, and that's okay, right? Because you know, there's some things are more animate than others, right?
If I might,
Wayne's had his hand up.
Oh, sorry. Oh, okay.
Yeah,
You got in there before you again, Steve. Sorry.
A few comments here. So, number one on consciousness. See that there's really a lot of problems with these kind of terminology. What we mean exactly by consciousness is very unclear, and it's been used in a bunch of different ways. You know, so I don't know. For me, the way that consciousness is talked about by folks like Whitehead and Peirce, like that sort of type of pan-experientialism makes more sense than something like assuming consciousness in the way that human beings normally, you know, a self-aware kind of consciousness. You know, these are different phenomena. I think they're on some kind of a scale, and there's some kind of cognitive glue where they can ratchet up to more complex structures. But anyway, Charlie, you were talking about problem solving. You know, a couple of things about problem solving. You as a human being who is actively using your sort of linguistic mind to solve a problem needs to be aware that there's a problem there. An organism that is suddenly finding themselves with not enough glucose around, but possibly a source of galactose or something nearby to continue doing what they're doing, isn't going to think about the problem the way you are, but it's still a problem for that organism. A lot of times when we talk about problem solving, you know, we're always assuming a certain perspective, right? I see this as a problem. Does the organism see this in a problem as the same way I do? Or is it a problem in some kind of a universal sense? You know, maybe not. I think the way that Richard's using it to be able to actually do experiments and get some answers to some questions is a pretty useful way to do it. And as long as we don't get too married to some of the terminology that we're working with. That's all.
Mary?
Thanks, Charlie. So, I'm a trained musician. I'm a vocalist and a composer. And when I moved into the house that we live in now, it's an old wooden house made out of a nice soft wood. A lot of the wood in here is fir, which is what a lot of stringed instruments are made out of. I walked into it and I sang a little bit, and I said, this house feels like musicians have lived here before. And the realtor said, oh yeah, everyone that we know of has been a musician. So I just accepted that as, oh, I was picking up the sweetening of the room that had happened by the music being played, which musicians accept as an a priori. It's normal. I mean, there's a lot of mythology about the Stradivarius violins and how the sound improved exponentially when this maestoso played in this one. But it seems to me obvious that that this is something that I haven't looked at the acoustic literature, but I had decided I was going to do that before this meeting for your sake, Richard, and I apologize that I didn't. But this seems to be in line with your learning spring experiment. And I think that it's a useful question to answer as an a priori as we move forward. But I did put in the notes this concern that I have about creating a metaphor based on biases that are very common in terms of our understanding of music, which aren't brought out in the literature, which aren't borne out by the literature. Like, for example, this idea that organisms are more responsive or create more of what we think of as harmonies, when the truth is that the literature shows that even in humans, babies do not respond more to harmonic versus what we think of as harmonic or what we think of as dissonant music, that is unculturated. And when you think of the fact that, you know, dinosaurs had whistling cavities in their skulls, and birds whistle, and birds, you know, sing in pentatonic scales, and humans, I believe, and this is something that I've been working on natural music theory for, is that we co-evolved together our sort of understanding of, you know, music as you know, vertebrates, but maybe it's different at different levels, and maybe they're the harmonies that we understand are the crude, non-complex harmonies. But when you think of the overtone sequence, every note is eventually included in it, and every note is eventually considered a harmonic. So, Richard, I sent you some stuff about this very problematic and difficult theory of music, the tritave versus the octave theory. And it seems to me that these ideas aren't going to be proven out until we can get outside of our vertebrate biases and start looking maybe at some other theories of harmony.
Yeah. Stephen, did you have something to say earlier?
I just lost. Wait a minute. Oh, I have to press this. Okay. Yes, I think all of these issues about the purposefulness or problem solving or incentive motivation and all of this can be exemplified with a very simple physical system, a little raindrop falling through the sky, and as it falls, it feels its own mass. It has its own permanence of existence, but it also has surface tension around the outside that holds it into a sphere. Now, when a gust of wind comes and pokes this raindrop on one point, that surface can be thought of as a sensory surface, and it's picking up a sensory input from the outside world. And in the inside world of the droplet, all this water that's being displaced has to displace other water, so the first derivative is going to push back against it, and then when it comes to, you know, pattern formation and symmetry, the rain droplet will end up wobbling and bobbling in some kind of symmetrical way that's a response to that disruption from the air. And this oscillation has a certain permanence to it, and it's fully reified. Every part of the droplet is participating in it. And now the only thing missing there is a long-term memory. It has persistence memory, and once you set up the oscillation has memory for a short period before it fades. But all of those exemplify what you like to talk to as cognitive functions. Without the long-term memory is the only part that's missing there.
Adam?
Yeah, just to briefly follow up on Mary's comment, I think it's really interesting to think about the sort of ratios of frequencies and how those play out in different contexts. I didn't know about, you know, infants, for example, but there's also a sort of, from my standpoint, like an information view on these ratios of frequencies, and that certain ratios of frequencies are conducive for, or more conducive for, like information transfer than others. You know, if I have a tuning fork and your tuning fork is perfectly tuned, then when I hit mine, yours is going to resonate. But if they're off by, and if they're off by an octave, they will still resonate. But if they're off by some other ratio, then it might not resonate very much or at all. And so that seems to suggest that there is some physical fundamentalness to this, even if it's not an aesthetic one.
I just respond. So octave theory is one way of demonstrating harmonics that we can hear and understand, and that we can understand in terms of physics. But it may be that life at different levels, or in different evolutionary lines away from, as I said, I should have actually just said the chordates, not the vertebrates, because fish sing to each other and so forth. It could be that their understanding of harmonics is more complex, and it's not based on the octaval theory, which is the most obvious that we can see. That's all I was saying. And I can share an article about the a very weird scale, the tritave scale, and how harmonies are worked out in that. If you listen to it for a while, it starts to make sense. It's this plasticity that Michael Levin is trying to demonstrate in so many different ways. All of a sudden, this thing you've never heard before, which is based on some arcane mathematics, starts to make sense to you.
Interesting. I'm going to check that out.
Yeah, share it, please. I'd actually like to see that. Alan Holdsworth I don't know if you guys are familiar with the British guitarist. He basically
Yes.
developed all his own scales. I mean, he's an amazing musician, but he built harmonies on top of these other scales, and they're not octave. they're something else. I'm not sure what they are.
There's a lot of different theories of tuning. And we're used to hearing the well-tempered clavier, where all the notes have been evened out so that they're in equal spacing between each other. That was one of Bach's innovations. Actually, there was one after that where it was called equal temperament, where every note is equaled out, but that's not actually the way the harmonic sequence works. The distance between the octaves, I believe it gets shorter as you go up. And so we're used to hearing things in a way that is supremely dissonant, believe it or not, based on.
So I would point out, though, I think what Adam is kind of talking about here is that there is sort of the underlying mathematics and physics when you're talking about information transfer and resonance and constructive versus destructive interference at different time scales. So there may be something special about particular types of harmonies in terms of being able to transfer information and how much information can be transferred. I'm saying it's worth thinking about also.
I think of this, the subjectivity question and the question of beauty as really fundamental. And it's always seemed to me that whatever patterns, like the reason why there's a sort of transmissible cultural definition of beauty is because whatever patterns are already within us are boring, and whatever patterns are too dissonant are just incomprehensible. They're just chaos. And so there's some magic in between where things are barely perceptible, barely understandable. And we, however we're set up, we're set up to, we're drawn towards those things that are orderly enough that we can sort of grasp them, but not quite all the way. And we want to grasp them more. We want to harmonize with them.
And that in between isn't just a midpoint on a linear scale. So that in between is a high dimensional space that's different for you than it is for me, right? Even though the start and end points might be the same, right? The way that the intro you need to give me for me to be able to hear it is different from the intro you need to give you for you to be able to hear it, right? To turn our internal models around so that we hear the same thing requires us to be loved by the introduction so that we can see the beauty of the thing that we're being shown. And that's not the same path for everybody. Hey, Mary Ellen, I wondered if you were familiar with Marianne Armature and the living sound stuff. It's I can send a link for that. She does this.
Let's just see it.
Sorry?
I would love to see her work.
Hear it. So she does this work with difference tones, right? So you have something playing two tones which are a little bit different from each other, and that creates, I was going to say the illusion, but it's still just as real, the tone that's the difference between the two frequencies. And
yeah, we do that in overtone. We had an experimental choir for a long time, and we use that in overtone singing all the time.
right,
And you can't
so
go to the piano and find those tones.
he
They're
uses
microtone. It's microtones, and you can't even describe them using the sorry.
so she uses those in compositions. And what I find that's interesting about it is that uh, as you begin to listen to it, it's almost like that there are ghosts there, that you can hear these other tones there, and it's like, shit, will you just turn off that annoying whine so that I can hear it more clearly? And it's like, well, no, you can't turn off that annoying whine, because that's the thing that's those two, the interference of those two whines is the things that's creating the ghost. So you can't turn it off, you can't isolate it. But as you listen to it, you can hear the melody that's in the difference tones beginning to develop in such a way. It's fucking spooky, by the way. For me, it really makes the hairs on the back of my neck stand up.
I'm really interested in that. So, did you know that in an orchestra, the piano has equal temperament, but the stringed instruments are tuned to a more Pythagorean tuning?
Oh, interesting.
And our ears, we've trained ourselves in the Western world to tune out the microtonal dissonances so that we can actually hear them together.
Oh. Now, I wanted to show this to somebody else, but it's quite a long piece and we didn't have that long. So I tried like, oh, the intro's a bit boring. Let me fast forward a bit and I'll show you the middle. And it just sounds like shit. And it's like, I don't get it. What am I listening to? Right. It's like, oh yeah, of course. You can't just jump in at the middle, right? You have to
get and trained to it. Yeah. You have to go
minutes.
through that plasticity process. Yeah.
Yeah. It's really cool. I'll put a link in there.
So I want to ask a question about long-term memory. I have a thought experiment that I want to try. So I think most of us have this metaphor in our minds that's from the current paradigm of neuroscience, which is that, when we create a memory, our brain is wired and it has something to do with connections, right, between one neuron and another. And I wonder if what we're saying about resonances is correct, then and what the way I understand what you're saying, Richard, about multi-level communication, suppose we had a sort of tub of water droplets, but they all had little they were separated by membranes, right? So they were tiny little vesicles. They didn't have any DNA or anything like that, but there were just 3 trillion little vesicles all in a tub.
30 trillion, yeah.
Okay. and then we had connected to these vesicles, we had like mechanisms for detection, for perception, right? We had like video cameras and microphones and whatever sort of detection mechanisms we wanted, and they all communicated via either
fashion state,
some sort of vibration or electrical communication with this tub full of vesicles. And my question is, do we have the intuition that those vesicles would develop a long-term memory? I mean, in principle, they could interact with the world if you just also had something sensitive to their own pattern of vibration that was connected to some actuator, some robot somewhere. The robot had all the sensors attached to it. But my question is there something physical something more permanent that has to be established to cement the resonances in place? Or is it just the resonances themselves? I mean, if these water droplets, maybe we would have a problem of them maintaining their energy level, right? They would have to be somehow supplied with energy to keep resonating in the right way. But that seems like a solvable problem, or is it something like, I think that's part of where my intuition about the natural induction springs experiment sort of feels something resists in my mind when I imagine that experiment, because I'm like, oh, well, the springs depress and then they kind of stay depressed. They're kind of broken. They don't like rebound into a more springy spring. Like once a spring is kind of de-sprung, it's kind of screwed, and so yeah. Is that a
yeah, good question. So there is a disconnect, a bridge that hasn't been built yet between the natural induction in the particles and springs and the more ephemeral notion of structure in the songs, right? So the connection between oscillators in the song story is about their resonance, which isn't a physical connection. It's a more like a broadcast sender and receiver sort of thing, where the particular sensitivity of one oscillator to another is the virtual network. And as oscillators resonate with one another and produce a difference tone, then they produce that produces a virtual connection with other oscillators that are oscillating at the difference tone, right? So then you have something which is changing the nature of the relationship between others. What's exciting about that for me is that it means that the topology of the network that is doing the learning is dynamic, right? That it depends, that the frequencies that you're oscillating at change the topology of the connections which are communicating those oscillations, which you don't have in the particles connected by springs. And the other thing is that it gives you this, the way I imagine it, like this is all just me like doing hyperbole based on, if you right, three facts and then a whole bunch of hyperbole. The way that I imagine it is that that it gives you the scale, the scale invariance, that it's not just linkages, but meta linkages and higher order linkages for free, right? Whereas the springs are just one level of network, and and that's it.
Richard.
So to answer your question, Charlie, about do the springs sort of give up and then it's game over? A spring is sprung. I wonder where the birdies is. What you need for that not to be the end of the story is a meta spring that determines how the length of one spring oscillates with the length of another spring, right? So that would be a higher order spring that connects them. And the natural induction model doesn't have that. But what I'm hoping to construct from the songs is a model that does, right? I mean, you could build a literal system of springs that with the appropriate kind of mechanical linkages would do that. But I don't think that it would have the same problems with doing deep learning that deep learning neural networks have. Whereas my aim with the songs is that you'd be able to do the deep learning without the problems that deep learning neural networks have. Sorry for not letting you in, Wayne.
Wayne's hands up. I think you're muted, Wayne.
That's okay. Yeah. No, that's all right, Richard. I was going to ask you this question in particular here, Richard. So a lot of this stuff, we're sort of ignoring energetics in a lot of this conversation. So one of the big differences between, and again, I think it's a difference of degree all up and down the line in most cases, but with organisms, they use some of the energy that they get from the environment to construct constraints that allow them to get more energy, right? So how do you get from, simple resonators in an excitable medium to something that's capable of harnessing energy on its own, without any outside driver, like you were talking about in your bathtub, where you're going to need some kind of external energy source. And, the reason Bob, almost done. The reason I point this out is that if you look at the difference between a basic self-organizing system, like say a tornado or a whirlpool, something that has emergent regularity, one of the things that these systems always do is that regularity destroys that external energy source as quickly as possible. It's just the fastest way to dissipate it. What organisms do is something very different. They actually extend that dissipation path length and redirect that external source to, in many cases, build new constraints that will allow them to do different types of work. So the question is, how do you get from this sort of basic sort of, resonating engrams or whatever you want to call them to something that's capable of doing things rather than just having things happen to them?
Yeah, that's great. So I think that the inorganic energy dissipators, like tornadoes, as you say, they go from energy at one scale to energy at another scale very quickly and very directly, and dissipate it very quickly, right? And they don't create any structure along the way. The thing that's different about living structures, living systems, life, is that energy gradient creates structure, which slows down the energy flow, which creates more structure and more structure and more structure and more structure as you go. And I'm going to come back to that's to do with how many harmonic levels are there that are communicating with each other. And in the non-living energy dissipators, it's like you're going straight from one level to another level without anything in between. You didn't have any resonance structure that knew anything about the energy source, right? So for that kind of a system, the energy source just looks like an energy source. It just looks like a massive potential difference, and you just plug it in and you blow a fuse, right? Whereas to something which is organic, that means that it has a structure that knows something about that energy source, so that it isn't just an energy source. It's actually, it sees it as the mirror for its own agency, right? It's like the environment to itself, the energy source. It's like the difference between whether I see a rabbit as a rabbit or I see a rabbit as meat, right? If I'm just gonna burn it or eat it, right? I'm not seeing the complexity of that. I'm just seeing it as an energy source. Oh, I'm not doing rabbit ears. Whereas if I interact with it in a way that gets to know it, right? That's because I have internal structure that is able to resonate in a way that induces knowledge about that individual agent. And that's what enables the slow dissipation of that energy, which creates more structure along the way. It's not like I can build a model of that, but that's the sort of vision I'm aiming for. I think Lars was in there, right?
Lars, you had your hand up.
Thanks. That was really interesting. I wanted to kind of pick up on something that you just mentioned there at the end of what you were discussing before about this approach in your mind being able to solve problems that deep learning has trouble solving. And basically just ask if you could maybe just unpack that a little bit, both in terms of, what kinds of problems this would be able to solve that deep learning has trouble with and why. And also just, I think what piqued my interest there was it kind of alludes to a more sort of sophisticated articulation of a toolbox here that is applicable in some ways that I hadn't realized was maybe there. And to actually be able, how would you actually apply this to solve a real problem?
I mean, so again, I have to prefix all of this with this is all just hot air, right? So here's what I think is wrong with deep learning as it is. It's like, in order to you start off with a network that doesn't have any preconditions. It has an inductive bias, but it hasn't learned anything yet. And you want it to build a model of your data, which learns really deep symmetries and mesoscale symmetries and lots of fine scale symmetries. And you can think about that as different levels of the architecture of the network taking care of those different kinds of symmetries. But the problem will be that after it has learned one structure, you can fine tune it a little bit more. But if you want to change a deep fold, a deep structural symmetry that you have learned, you're in trouble. Because the only way that you can change the deep structure in the network is through the fine scale and the mesoscale structure. So to change the deep fold, your options are either, fuck it, let's just flatten everything and learn something else on top. Or you have to very, very carefully undo all of the fine scale and all of the mesoscale so that you can get to the bottom, change it, and then relearn all of the mesoscale and relearn all of the fine scale. And a metaphor I have for that is, imagine that I had made a figurine out of clay and I wanted to change the pose of the head so that it looked the other way, right? Now, if one way to do that is that I could just push it, I could just push it hard, right? And that would just, it would turn the head to face the other way, but it would smush all the features on the face, right? So that's trying to speak directly to the deep structure, but it's ignoring the fact that it doesn't self-sustain. It's all of the different levels of all the other levels of structure. It won't reconstruct the mesoscale and the fine scale features after I've turned it, right? So my other option is that I could push it little bit by little bit by little bit by little bit. Like push a little on the nose, a little bit, push on the brow, a little, push on the ear, a little tiny little bit at a time, so that I very, very slowly turn it, right? So by talking through the fine scale, I can control how the fine scale moves in such a way that it moves the mesoscale and the macro scale down to the deepest levels and turn it around without smushing it, right? So my options are either smush it and then learn it again, or with an exponential amount of data, just, turn it very, very slowly in that direction, right? Now, with a living thing, you can speak directly to the bottom level structures of things without obliterating the mesoscale and the fine level structures of things, right? You can say, I'm gonna blow your mind. I'm gonna change your world. I'm gonna give you a revelation which makes you think about everything differently. And in so doing, for a moment, it feels like shit. Like, the universe works a different way than I thought it did. But everything that you thought you knew before suddenly starts to sort of fall back into place, and it turns out, oh shit, turns out I'm still the same person on this other side, but this deep commitment that I had to something has shifted inside, right? You can't do that with deep learning neural networks that we have right now. And I think that you can with a harmonic stack, right? With a resonator that is built of multiple levels of frequencies that are resonating with each other. You can hum to it at the low frequency and change the phase of the low frequency without going through all the other frequencies.
Right.
Mm-hmm.
Right. But how?
That's
that
is it.
Sorry, Mary has her hand up.
If the thing that it's learning from is a thing like it, then it will already be singing in all of the frequencies, right? It's not, you don't communicate just through the high frequencies. You communicate directly through all of the frequencies. It's like a multi-frequency bandwidth thing that's going on.
Well, except that there's
love that.
There's significant details, right? I mean
come on, the details are going to be fine.
No, I mean, in perception, right? We skip over everything that we expect to see, and we notice the one thing we didn't expect to see, like if I'm driving down the road near my house, I pass probably 10,000 trees on my way to town. But the first time one of those trees turns purple, I notice it, it jumps out. I didn't expect a purple tree, and so there's a selective bias that's sort of imposed on the data, like, from the bottom up, from my internal structure imposed these expectations. And then when experiences at variance with those expectations, that's when I'm changed.
Yeah, I mean, if you have a model which is a model which flows easily with your environment, that it knows that environment well, you can change those deep level structures in a way that's so effortless, it doesn't even feel like a transformation at all. and then the little bit of dissonance will stick out as like, you could have this complex symphony with just this one little ding that shouldn't be there, and that would just totally stick out. That makes sense to me. Even though you could, I could do another pass of the same thing, a variant of the same thing, and you wouldn't be the same, but you wouldn't feel the same salience of that feature.
Well, I think Lars's question also connects really deeply to this bigger problem with AI and machine learning, which is just the problem of induction, the problem that we're not averaging our past experiences to form the next picture we're expecting to see. There's no sort of averaging going on. Like when my little boy was introduced to cows, it was in terms of little plastic figurines that are white and black, and then he's told that these little figurines do something that is moo, and then we're like driving by a farm with real cows, and he looks out the window and he's like, without hearing any moo or hearing anyone say cow, he's like, moo. And you're like, what? Like, that's a totally different sense impression. Like the qualia of what you just saw is totally different from the little plastic figurine and the little routine we had in the living room of, playing cow with you is totally different. You just totally, recognize something that's completely unlike all of your previous experiences of moo, of cow, and you expected it to happen. Obviously, like he made the connection. So
that's a great example.
There's like this. So I think I really Steven's disappeared now, but he actually, I think, has solved this problem to a great degree with this harmonic gestalt thing that I want to get into the next time we meet, because it's really a fascinating exploration of how harmonic resonance can reify, can allow rotation. There are these like 4 characteristics of Gestalt theory. It's like multivariant, multi-stability, emergence, reification, and rotation, I think are the 4. But I don't want to spoil that or cheapen it by introducing it in a sloppy way. So let me leave that for later. But anyway, I think there's yeah, to me, the question is, how do we get from perception to understanding? Like not prediction necessarily, but understanding, which of course prediction is entailed by understanding.
Or it's not just understanding, right? But the ability to act, right? The know-how that is not even just an ability to act, but actually acting, right? Like actually putting that knowledge into action and being motivated to do so, rather than thinking of it as a homunculus, which is going to look at the understanding and then do something with it. It has to be know-how that that is agential, not know-how that agents use.
Yeah. Sorry, Mary has her hand up, but let me just be greedy for 1 sec. So I had this concept in my first paper, my first epistolution paper that I wrote forever ago, the concept of expect actions. Like I like to make up words, so I made up the word expect actions. And that was me like trying to give a term to the process that's not just like expecting something to happen, but involving oneself in the bringing of that thing about. That our cognitive horizon is the same as like our physical impulses in a certain way. Anyway. Sorry.
Sounds very active inference-y in the language.
Well, it is. I know it does, but it's not. But anyway, recognizing that I disagree with that, like Bayesian predictive processing model, and I think of it as something totally different, like expectations as being the result of an explanation of the world, not as a result of averaging past experiences, but forming an explanation, which is something totally different.
So I keep not knowing where to throw in because I'm a really divergent thinker, and I don't want to interrupt a flow that people are having. So I apologize for that. But the question keeps coming up for me of, if we want to really understand this question of agency, I think that I keep feeling and then coming up with logical justifications for giving physical matter more due, and trying to either include it or rule it out by paying more attention. And I keep thinking of piezoelectricity. One of the many things that I've studied and I practice in my shamanic practices, body work, and I work a lot with the fascia, and the fascia is piezoelectric, as are rocks and crystals in our teeth. And every time I get a feeling, I want to understand what's going on piezoelectrically with your teeth when you bite, when you chew. I discovered that there's a body of research on this. Where actually the enamel in our teeth are actually giving off electric signals when we deform or compress them. That's the sort of the definition of piezoelectricity. I'm not a physicist, so please feel free to laugh. But I'm wondering if we could, if you could gain some information, Richard, by measuring this effect with musical instruments that have been played a lot and musical instruments that haven't been played a lot, and seeing where this might fit into your metaphor, to see if you can rule in or rule out the contribution of sort of like the wood or the metal of the horn in actual music, and if that might fit into your model. And
Yeah.
again,
I
I
didn't see
apologize for
anybody laughing about the piezoelectric teeth, by the way.
what?
I didn't see anybody laughing about the piezoelectric teeth. uh, I'm curious about because some of the examples you gave about the musical instruments being sweetened by being playing were wooden ones, whereas the example that we started with, the trumpet, wasn't. And I wonder whether musicians have a feeling for that it's harder to sweeten the trumpet than it is to sweeten the
Well, you
violin.
see, now I want to go look at that, and I'm curious because the wood at least has the sort of like harmonic resonant shell of the plant cells, right?
Yeah.
The cellular lignin cellulose structure, and maybe life creates more resonant structures intentionally. That's a
Yeah.
really interesting question. So, a piezoelectricity of the lignin and cellulose.
Yeah.
Be interesting to
And
know.
it's mental that out of all of the possible things that you could make strings out of, that you still make them out of catgut, for fuck's sake. It's like, what
And
the
it's so.
hell? Like,
But
that's
again,
the best thing. It's like,
is it so? But these resonance ideas, I think, should be considered. And also, I asked you about this once, Richard. Have you looked into the electromagnetic properties themselves of sound waves? I think it would be really interesting to sort of like have a map of those turned into visual symbols that we could sort of regale ourselves with and enjoy as we're listening to music and watching different people play, and see how they might change. I'm always interested in sort of like what these other visuals might, visual ways of understanding things might be.
okay, I'll bump that up my list.
Wayne?
Yeah. One thing I just want to sort of mention here is when we're talking, it seems like at least in the last few meetings, when we're talking about knowing, we tend to it feels like to be really focusing on kind of propositional knowing, whereas something like skills, which are embodied and we sort of have touched on a little bit, can't be reduced to propositions at all. There's no closed form list that I can give you that'll tell you how to make a pot of coffee in a kitchen you've never been in before, for instance. And there's many examples of that. And then the deeper forms of knowing. I feel like maybe we should have one session on 4E cog sci, and bioinactives, because this is kind of an entire field that it seems like not everyone here maybe is aware of.
Can you summarize the insight?
Boy, it's yeah. So from John Vervaeke's point of view, he's probably one of the more sophisticated 4E guys. there's at least 4 fundamental types of knowing. They're each tied to different types of memories, and they're progressively deeper, right? So propositional knowing is what we're kind of familiar with in human experience, which has to do with writing and computation and all that sort of stuff. You can write it as a list of statements which are either true or false. Skills is what you would call participatory knowing. These are the things that you know how to do as an agent in an arena to whom affordances become salient. Does that make sense?
Sure. Yeah.
All right. Then at a deeper level, you have your sorry, you know what I just called? I should have called that procedural knowing. Sorry, that's knowing how to do, which is different than knowing that. Knowing this is true is different from knowing how to do, right? Then there's a level deeper. You have perspectival knowing, and this is kind of about your, as an agent, your sense of here-ness and now-ness from a particular place, embedded in a particular arena. And then even a level deeper than that is your participatory knowing, which is what it's like to be an agent doing things in an arena and solving problems that are problems from your perspective. And this come, and 4E means embodied, so that cognition is always embodied, where cognition means knowing, right? So it isn't necessarily computation, as that definition kind of got hijacked. There's embeddedness. So an agent is always embedded in a bunch of different arenas in which it can act and do actions. There's extension. So that, for instance, if I'm playing a guitar and I'm a skilled guitarist, or say a pool player, that instrument, which on the one hand isn't part of my body, on the other hand, it's an actual extension of my cognition, right? And then, I think we maybe should take a look at some of that sort of stuff, because it might enrich our thinking in a number of ways. And I could point to some things that could be read or watched that would explain this stuff pretty thoroughly within an hour.
Embodied, embedded, extensive, and inactive?
Yes.
Yeah.
And you can also extend that to a 50, which is exaptive, where, organisms will always find new purposes. This is part of the whole affordance and salience landscaping thing, is that if there's an adjacent possible purpose for something in a particular arena, organisms always find a way to make use of that.
Yeah. Well, that raises a question I wanted to ask you, Richard, before you run out of time, which is who have you discovered that likes to think about the world this way? Because I feel like I'm combing all over, but I still feel like there's this precious little tiny lifeboat of people that are thinking of evolution as learning first, and have really drawn those conclusions, and virtually everyone else is thinking of cognition as a result of evolution.
Yeah.
And that's a big difference. And so I'm just wondering, where can we find
so I think about my answer to that question in 2 different ways. One is that the number of people on this particular point on the bridge using these particular tools at this particular moment is small. But the communities that are connected by that bridge are potentially large, right?
Right.
You have to remember that when you say everybody thinks about cognition as being a product of evolution by natural selection, the everybody that you're talking about is not everybody. That's everybody that approaches things from an evolution by natural selection point of view, right? But it turns out, Mary Lynn can vouch for this, there's a whole bunch of other people in the world who don't come from that starting position, right? And they don't think about the world in terms of product of natural selection, and they do think about the world in a way that begins with subjectivity and begins with experience, and being able, the potential to be able to build bridges or portals that open up communication between those audiences. What I'm hoping is that it's like a chink in the dam, right? That at the moment it's just a trickle, right? And you say, oh, it's only a tiny trickle, right? It seems like a small community, but what I'm hoping is that the whole fucking thing collapses.
Yeah, well, but I think what you said earlier is so true, that we have to develop an empirical model in order to collapse anything, because no one takes it on just hypotheses and philosophical arguments, because people's imaginations aren't that capacious.
Right.
So
Exactly. Yeah. I have to, we have to build a working model, right, that demonstrates and illustrates those ideas and can connect it with all of the other stuff that we know from the conventional framings, right? Yeah, there's work to do.
I want to hopefully next time we meet we can discuss Fourier transforms also.
Get Stephen in that one.
Yeah, Charlie?
Yes, sir.
Just to point out, I agree with everything Richard just said. There's a small group that start with cognition. And we could rattle those names off. There's really only one comprehensive model that begins from the cognitive cell and works it through to its own end. And that's cognition-based evolution. It's there. People don't seem to care, but it already exists. People talk around the edges of it. But for those people that are interested, there's a fully worked out comprehensive model based on empirical evidence and moving forward through evolutionary spacetime. It's out there, it's published, dozens of papers, books.
I mean, in the sense of, I know there's like an intellectual model, but I mean in the sense of a physical model, in the sense
model, right? An algorithm.
Yeah, formalization.
Can you build it? It can't be formalized. That's part of the problem.
It's kind of a double negative, Richard, that not one of you can tell me that you could talk to me and say you're conscious, but I don't know. You're challenging me to build a model on something that we don't know how to model, and everybody agrees.
Yeah, that's why
I agree with William. This goes back to my original point. I feel like we're under the lamppost looking for the keys when the car's parked down the street, simply because that's where the light is.
Well, I'll say I feel a sense of frustration because I'm not saying that I have all the answers by any means. And I am certainly the first to admit that I do not know how cognition began. But it becomes our proper platform now that we know that it exists and has done continuously for 4 billion years. We might as well use it. I'll take the case of cancer. Lynn asked a great question. He said, well, what are we going to do with this? How do we put it into action? And there's a stark difference between a cognition-based model and a neo-Darwinian model for cancer treatment. For example, what do we do with cancer right now based on the gene-centric model that we have? We club it. We use S-phase poisonings to try to kill it. And we take the simple narrative of trying to kill the faster reproducing cancer cells compared to the slower reproducing normative cells. And you see the results all the time. It's highly destructive, and it's an ordeal. In a cognition-based model, which is based on the realization that cancer is an alternative engineering format with its own individual cognitive selfhood. And these are two competing entities. One is the cancer cell, and it's not playing by the normal rules, which we can identify. Anyway, to get to the quick point, because we're at an end here.
I'm so sorry, Bill, to interrupt you, but don't let me stop the meeting, but I've got to split now. Thank you so much, everybody, for the...
Thanks, Richard. This was really interesting. I can't wait to rewatch it as well.
Thanks.
Bye, everyone. Big love.
I agree with you, William. I think it all comes down to the hard problem. And we might have to change our priorities and just ask questions, presuming, you know, consciousness or sentience or some formulation first in order to be able to move forward, if I understood you correctly.
I do. We can solve biological problems to improve our lives in a very different manner by starting with the intelligent measuring
That's
system
right.
and going forward from there.
Yep, I agree.
And we make a lot of medical mistakes by not understanding that it's all about partnership and natural learning over time, and both cooperative and competitive engineering.
And levels of communication that we don't understand yet. We simply have no idea of them, and trying to figure those out first isn't going to get us there. I think that we need to be almost like microzoologists and study cell behavior as...
This is what Mike Levin's doing in his lab. Look at Mike.
Yes, Mike's
work. What he does.
He is doing that to some degree. Some of his a priori's disturb me, but that's a discussion for another time.
Part of the problem with Mike is that he uses a lot of metaphors and he doesn't take them very seriously. So he talks about a lot of models, and we have some priors where we think he's talking about universal computation. He doesn't really believe that these are things that are executable on a Turing machine. He just uses these models because it helps people sort of think about it, to understand what he's talking about.
Well, he's a great explorer.
Yeah, he is an explorer.
He's exploring cellular behaviors in a very innovative way. And by doing that, he's illuminating a lot of the cognitive agency that determines our health and evolutionary outcomes.
That's right.
Anyway, I have to go to. Thank you all.
It's good to meet everyone.
Thank you, guys. That was great.
You're all brilliant. It's a lot of fun to listen.
Thanks so much. We'll talk soon. Bye, everyone.
All right. Charlie, thank you so much. I know that I'm the wild card because I don't have the same background as you folks have, but
not at
I
all.
found this was really interesting, and I want to talk to everyone. I'm so introverted. I'm like, I couldn't follow. I want to talk to everyone individually.
No, you bring so much. Thank you so much.
All right. Great. Thanks, Charlie.
Okay, guys.
All right. Bye-bye.
Bye.